we have seen a Kubernetes architecture and we have seen a sample Kubernetes cluster with two working nodes and one master node or control plane. So now what we are going to do is we are going to jump into this cluster architecture and we are going to explore each and every component of this Kubernetes cluster architecture. We had begun with the API. So API, we have discussed about the API, and then after that Kubernetes API, we are gonna jump into a Kubernetes working node. A Kubernetes working node is part of Kubernetes cluster. Kubernetes runs your workload by placing containers into pods to run on nodes. A node may be a virtual or physical machine depending on the cluster. So don't get confused when somebody says Kubernetes node or agent or working node or master node or control plane. Don't imagine that, don't be illusionized that this is something different. No, not at all. It is just a machine, a virtual machine or an EC2 instance or any a physical machine or wire mainframe, whatever it could be, a machine or computer is known as a node in Kubernetes terminal. So normally we use a cloud, so that's the reason EC2 instance could be our working node. One EC2 instance is our working node or maybe master node. Similarly, if you use a physical machine where you have created a virtual machines, in that case a virtual machine could be our working node or master node. So each node is managed by the control plane and contains the services necessary to run pods. We have seen the control plane in our previous slide, which is on left portion of our slide, and the components on a node includes the kubelet, a container runtime, and the kubeproxy. Let me show that again. So the components of a node, a working node, specifically it's not just a node. Of course, if you say node means it's just working node. So because, but if you want to mention, if you want to I talk about a master node, you have to specifically mention either master node or control plane, whereas a normal node is also known as a working node. So this working node consists of three components. One is a kubelet, you can see this here, and other one is a kubeproxy that you can see here, and final one is container runtime engine. The container runtime, that could be a Docker. Here we are using Docker. This is most famous tool. So there are two main ways to have nodes added to the API server. API server is this. So this is what is our API server. We have discussed about the API server just before. Now there are two main ways to have nodes added to the API server. One, the kubelet on a node self-registers to the control plane. This is what this kubelet automatically self-registers to the control plane. This kubelet will do that act, or another human user manually adds a node object. These are the two ways. Either kubelet will do the same work for you, or else you can manually add a node object to the API server. So after you create a node object, or the kubelet on a node self-registers, the control plane checks whether the new node object is valid. For example, if you try to create a node from the following JSON format, I'm going to show that. So this is what we are using. with this following JSON format that you can see on your screen. If you try to create a node from this is called JSON manifest. So Kubernetes creates a node object internally, the representation. So Kubernetes checks that a kubelet has registered to the API server that matches the metadata dot name field. Here is that metadata dot name field. So this is my first K8s node. Okay. So the practical demonstration of all the objects, all the Kubernetes objects like node, pod, and secrets, config, and many, all we are gonna do in our objects, Kubernetes objects section. But for now, we are going to understand the subtle differences and then the core concepts in depth of every component of cluster. That's what we are doing here. After that, we'll do all the demonstration of each and every object of Kubernetes. So here the Kubernetes checks that a kubelet has registered to the API server that matches the metadata dot name field of the node. If the node is healthy, that's all necessary services are running, then it's eligible to run a pod. Otherwise, the node is ignored for any cluster activity until it becomes healthy. Note that Kubernetes keeps the object for the invalid node and continues checking to see whether it becomes healthy. You or a controller must explicitly delete the node object to stop the health checking. So the name of the node should be given to check that. So node name uniqueness. The name identifies a node. Two nodes cannot have the same name at the same time at any cost. So Kubernetes also assumes that a resource with the same name is the same object. In case of a node, it is implicitly assumed that an instance using the same name will have the same state. Example, state here means similar kind of network settings, root disk contents, and attributes like node labels. Everything remains everything similar. It assumes that everything same. So this may lead to inconsistencies if an instance was modified without changing its name. If the node needs to be replaced or updated significantly, the existing node object needs to be removed from API server first and re-added after the update. So now first we will look into self-registration of nodes, because we have discussed about two types of registration. The concept is pretty simple. So I will take you back to the previous slide so that it will be much clearer. See, here we have a master node. That means that is, let's consider it is one EC2 instance, and this is a working node, this is another EC2 instance, and this is working node, another EC2 instance. So that what we are going to do here is we have created three EC2 instances separately. Okay, now I have considered this as a master node or control plane. In this, I have installed the required tools or required utilities. Now, the one more instance I have is EC2 instance. That EC2 instance, I want to consider it as a working node. Absolutely fine, no issue at all. But how would the master node understands that this is a working node? How would the master node get to know that that is his son? Let's take that example. How would your father knows that this is his son? Obviously, there is some connection. The name is given. He knows from the childhood because it is inherently connected. It is self-registered because it has come from him after your mother tells him. Okay. So here also the EC2 instance has been created. Now we have to make a connection between master node and working node. For that, we have two methods. One is self-register, second one is manual register. For self-register, automatically self-register will be done through kubelet, whereas manual register, you have to do that. So once it has been registered with once once it's been registered with once it's been registered with the master node, that's it. The system considers it as a working node, and it will do the health checkups, and if it is absolutely healthy, then the master node will allow the working node to make pods inside that. So that's what we have discussed so far. So now let's move ahead. So now how the self-registration of nodes takes place. That's what we are going to do. So when the kubelet flag registered register node, the kubelet flag register node is true, the kubelet will attempt to register itself with the API server. This is the preferred pattern used by most distros. I'll show you that code first. Yeah, this one. So if you use that register node, I'll show you that. Yeah, this one. This option automatically register with the API server. Just remember this or write down these flags or options on your notebook. When the time comes, we will put into the action. We will take them and we will put these things into the action. Okay. So then uh, for self-registration, the kubelet is started using the following option. One is the kube config flag. So it is path to credentials to authenticate itself to the API server. First one, authentication will be done. Then cloud provider. If it is a cloud provider, how to talk to a cloud provider to read metadata about itself. Then register node, we have seen it. It's automatically register with the API server. Then we have register with taints. So register the node with the given list of taints. So we have to mention the key and value pairs there, and then node IP. So IP address of the node should be provided, and node labels we can attach labels to that, labels to add when registering the node in the cluster. Then we have a node status update frequency. So specifies how often kubelet posts its node status to the API server. So these are the widely used flags when you register your nodes to the API server or to the master node. Unless you register your EC2 instance or virtual machine to the API server into the master node, it will never consider it as a working node. I hope it's pretty much clearer. It's pretty much clear. Then we will look into the manual node administration. So you can create and modify node objects using kubectl. When you want to create node objects manually, set the kubelet flag, that is register node. The register node, you remember that flag. We are going to use this register node flag. You put that you set it as false. So you can modify node objects regardless of the setting of register node. For example, you can set labels on an existing node or mark it unschedulable. So you can use labels on nodes in conjunction with the node selectors on pods to control scheduling. For example, you can constrain a pod to only be eligible to run on a subset of the available nodes. So marking a node as unschedulable prevents the scheduler from placing new pods onto that node, but that does not affect existing pods on the node. So this is useful as a preparatory step before a node reboot or the other maintenance. So this step is also pretty much important, that what do you call that, uh, labeling and unscheduling. Labeling and unschedulable. So these things are also pretty much usable to mark a node unschedulable. So for that, we can use kubectl cordon. This is a recent one. You can use that. So pods that are part of daemon set tolerate being run on unschedulable node. But daemon sets typically provide node local services that should run on the node even if it is being drained of workload applications. So if you want to mark a node unschedulable, you have to run this kubectl cordon and the name of the node that you have given using a label. Then now let's look into the node status. A node's status contains the following information. One is addresses, the second one is conditions and capacity and allocatable info. So you can use kubectl to view a node's status and other details. So but how can you use that? So when you look into the addresses, the usage of these fields, for that the command that you have to use is kubectl describe node. When you mention kubectl describe node and then you have to insert the name of the node there, then it will show you the required information about the node. So the information consists of addresses. The uses of these fields varies depending on your cloud provider or bare metal configuration. However, few components of these addresses are common, that is host name. The host name as reported by the node's kernel can be overridden by the kubelet, so host name overridden parameter. You can use the overridden host name overridden parameter to override the host name. Then in the Kubernetes API, a node's condition is represented as the part of the status of the node resource. For example, you can look into this conditions. You can look into this conditions file. Okay. Now, this example describes a healthy node. Last heartbeat time, last transition time. So it literally uh, uh, basically represents a healthy node. So then external IP will have an external IP and an internal IP as part of the kubectl describe node data. Then we will look into the conditions. The conditions field describe the status of the running nodes. So some of the examples of the status of the running nodes are ready, disk pressure, memory pressure, PID pressure, network unavailable. So disk pressure will get it true if pressure exists on the disk size, that is if the disk capacity is low, otherwise false. Similarly, PID pressure, that is process ID pressure, and we will get a ready. If we get the ready status, a node condition, then if the node is healthy and ready to accept nodes, accept pods, if the node is absolutely healthy and ready to accept pods, then we will get a ready, or else we'll get ready false. Then that means the node is not healthy and is not accepting pods and unknown if the node controller has not heard from the node in the last node monitor grace period. Default is 40 seconds. So that's what the condition of nodes basically convey. Now let's look into the capacity and allocatable. This capacity and allocatable describes the resources available on the node, such as CPU, memory, and the maximum number of pods that can be scheduled onto the node. That's what this capacity and allocatable section of the node's description will tell us or convey us. So the fields in the capacity block indicates the fields in the capacity block indicate that the total amount of resources that a node has. So when we work on with our objects, that time we are gonna experiment all these things. Then we have info describes general information about the node, such as a kernel version, Kubernetes version, kubelet and kubeproxy version. So container runtime details and which operating system the node uses. The kubelet gathers this information from the node and publishes it into the Kubernetes API.